Capital One is our sponsor here at OSCON for a day of discussions about open source and why it is so important for new stack organizations everywhere. Capital One is at the forefront of this new open source world with several efforts such as the opening of its APIs and open sourcing core technologies such as Hygeia, its DevOps dashboard. Learn more about Capital One and its focus on developers at developer.capitalone.com. Hi, it's Alex Williams of the New Stack here at OSCON talking with the team from Bitnami and Jeff Meyerson of Software Engineering Daily. Jeff, great to have you on our show as a co-host.
Thanks for having me.
Great. And the Bitnami team is one that I've known over the years and started to do some really exciting things. You always have been, but I mean, just now with the container technologies that you're building out. And really what I want to talk about here is, thinking about the open source communities and thinking about open source and how you guys are playing in that ecosystem. And perhaps that would help us kind of provide some perspective on like your role in, for example, in Kubernetes and your role in kind of in the Docker ecosystem. And I'm sure, Jeff, you could probably have some questions and some thoughts on that as well. So, perhaps, we should just start with, David or Erica, helping us understand, who you are and what you do, and just for background here with Erica Brescia, who is one of the co-founders of Bitnami, and David Dennis, who is Vice President of Marketing at Bitnami. So tell us, Erica, maybe you could just tell us a little bit about the company, and then we can go from there.
Sure. So Bitnami provides essentially an app store for server software. So we package over 130 open source and commercial applications and make them incredibly easy to deploy both behind the firewall and in the cloud. So as a user, you can come to Bitnami and choose an app like WordPress or Drupal, or a development environment like Node or Rails, and you can install it on your laptop via a native installer or run a VM, or you can deploy on any of the major cloud platforms, including Amazon, Google, Microsoft, and Oracle. And the apps are freely available to users, and we keep them constantly maintained and up to date. So, recently there have been a ton of different CVEs issued, and we rev all of our stacks and push them out across all the environments that we support within 24 hours. So what you're getting is always consistently configured, ready to run, and up to date. And as you mentioned in the intro, we recently started releasing containers as well for the applications that we package.
Jeff, any thoughts or questions?
Well, my biggest question would be, since you guys interact with all the major cloud vendors, how you project the competition between different cloud vendors into the future, because I see it as two, if I were to portray it as two polar potential futures. One would be where all these cloud providers are providing similar types of services, and then another type of future would be where there is increased specialization, like Microsoft provides a type of cloud that would be particularly vended to business users, and Google would be particularly vended to people who want to run their own data center and have the granularity of Kubernetes. So I'm really interested in what you see as the future and how these different giant cloud providers are going to shape up.
Yeah, I think you're already seeing it. You're seeing differentiation based upon the target markets they're going after and the specific technologies that they're investing in. So I think the most recent example that really drives it home, if anybody went to GCP Next, the Google show, Google put a lot of emphasis on what one might call kind of the scientific computing aspects of their cloud, things like the machine learning application, things like the Vision API, things that rely heavily upon the PhD level R&D stuff that Google itself has invested a lot of time and money in for all of the other moonshot type of projects they're doing, including various kinds of AIs and things like that. And now they're investing heavily in bringing in the cloud, and they were talking about that a lot at the conference. So they seem to be saying to people, of course they need to provide basic infrastructure functionality, but they're also saying, like, if you want to do any of these kind of compute intensive things that rely on more than just sheer horsepower, that there's some intelligence in the algorithm, there's something else more sophisticated going on, they want to be the place to go and do that. Microsoft's not playing that particular card, right? Microsoft's playing a very different card, which is they're going to say, okay, if you want a heterogeneous, system that has, some Microsoft components in it and some open source components in it, and you also want to have new updated versions of things like, the Azure Service Stack, for example, built within Azure, and you want to combine that with open source components and then have a certain level of enterprise street cred, that seems to be, the card they're playing. So I think both of them feels that that's different from what Amazon's offering. I think at the other end of the spectrum, you're getting guys like GoDaddy who are coming in at a SMB level, which is sort of a new approach to the market, and they're going after people who perhaps would not have been people to go to the cloud or go to Amazon maybe 2 or 3 years ago. And I think in the case of somebody like GoDaddy, they're saying, okay, we have a comfort level with a user base who's used to us as a hosting provider for SMB type web services, and they believe that they can bring some of those people into the cloud by targeting, again, a particular niche at SMB. So you're getting to the point already where what you're talking about, it's already happening. And I think people realizing that just having a price war with Amazon is not a smart thing to do. So you need to absolutely go over after differentiated markets, and both the combination of who do you have a footprint with, who do you serve well on the customer service side, which is, for example, GoDaddy's strong suit, but also specific technology pieces that map well to that particular market.
What about the types of customers who don't want anything to do with any proprietary APIs? They don't want to do anything with Google's machine learning. They don't want to do anything with Azure's database. They don't want to do anything with Amazon's elastic load balancers. They want completely commoditized compute. Is there going to be this layer that is over all of the different cloud providers where it's kind of like an arbitrage layer and you can get whatever commodity compute that you want from any cloud service provider?
I mean, people have talked a lot about
for such a long time
wanting to have that. The question is that's some pretty heavy lifting on the engineering side, and in whose economic interest is it to build that? Right. So one could argue that it's
the
not
developers' work time.
Yeah.
Developers' budget.
But if we're saying like somebody with deep pockets, a big corporation, you say, well, it's not exactly in Amazon, Google, or Microsoft's interest to do what you're saying. And perhaps there will be some funded initiative somewhere to do that. But I think at this point in time, there's not an obvious grassroots route to market for that unless a large consortium of developers are willing to tackle that problem, kind of for free.
It does seem to talk to the cloud native discussions we're hearing, and the efforts around Kubernetes, and we're hearing more about integrations with OpenStack, for example. But still, there's still a lot of silos there. Aren't? I mean, AWS doesn't support Kubernetes, right? Microsoft, I don't think doesn't support Kubernetes. So that seems to be the age-old problem.
Well, the cloud vendors are going to do everything they can to make sure that doesn't happen.
Right.
Like David said, it's not in their best interest. And when I think about the economics of something like that, it would be really hard to make it make sense because the cost of computing is already going to zero as it is. Who's going to make money off of that extra layer? I just don't buy that there's a big enough business there even. So like you said, maybe there will be some open source movement around that, but don't forget who developed Kubernetes and who has a very strong
Google.
interest. And I mean, obviously it's part of the Linux Foundation now, and it's out there in the open, and there's a huge and great community around it. But where do you think Kubernetes is going to run best, right? I mean, it's still not completely, totally neutral, in my opinion.
So is this multi-cloud discussion, is it really not realistic at all?
I don't think it's completely unrealistic. I think that there are organizations who have a risk profile enough to where they can say, we don't want to be shackled to one particular cloud vendor for corporate or organizational, vendor lock-in fears, right? Somebody who can say, we're comfortable running in the public cloud, and get over the security and other challenges that some people feel the public cloud happen. But at the same time, we're not comfortable being locked into a single cloud.
Right.
And they themselves might develop it. If you're an organization that says, we can't afford to be saddled to just one cloud. We need to have the ability to work on one cloud, or else, it's too crippling to us if something happens, or from a leverage point of view, economically, right? I could see absolutely an organization doing it to scratch their own itch because it's in their economic interest to do so.
Right. So how does Bitnami adapt its own open source efforts to this, very much, these very different cloud service environments?
You want to talk about that one? Yeah.
Sure. I mean, there isn't standardization, right? So we spend a lot of time, we work directly with the engineering teams at every major cloud platform to do a lot of integrations to make sure that we can get, from a built and known good and tested image into their platform as quickly as possible. And one of the other things that we spend a lot of time on, and you'll see more of this from us this year, is tuning the images to work out of the box with some of the services that come from the cloud vendors that you were talking about before. We already incorporate monitoring and logging agents, for example, from Google into the images, and you can turn them on or turn them off. But the idea is to make the apps run out of the box on each cloud as well as possible, and give people the option, if they want to, of hooking into all those different services. But there's not a one size kind of fits all approach.
No.
It takes a lot of engineering effort, and that's why our team's been growing so quickly, is because there's a lot of work involved in doing that.
So how is that then? How is that played out in your own container strategy? Open source. Your open source approaches as you kind of think about these very distinctive cloud services.
So this is something where I think we've had to go through a lot of painful learnings that everybody else has had to learn, right? And among the aspect of how do we build containers better and faster, which is something that our Stacksmith product helps you do, and it also notifies you as update and keeps them current, which is a big part of it. I think the other part of moving to containers that people are only now starting to get is to say, okay, if I'm going to be running this in production, what does this mean for how do I manage the life cycle of the container, and how does it fit with a CI/CD system, and how does that fit into an orchestration system? And then once they start to do all that, they start to have the realization that this is very different from doing virtual machines, that most of the practices that they've been following for more than a decade are going to, at a minimum, have to be tweaked, or in some cases completely be re-examined. The paradigm shift of going from a physical server to a virtual server is not a huge one. The paradigm shift from going from a virtual machine to a container, it's a big one. And I think now people are starting to realize not every single application out there, open source or otherwise, is suitable to be run into a container. There's some things that it just doesn't make any sense. The other part of it is, if I have an existing set of application stack in my IT environment, and I don't have the luxury of saying, okay, I'm only 3 years old, I can start from a greenfield opportunity. How do I fit containers into the larger ecosystem of stuff that's maybe a little bit old and some stuff that's ancient, and how do I roll it all together in a way that provides a coherent best case use where I'm going to use containers where it makes sense and it gets good ROI, and I'm going to have some other stuff that maybe they're going to stay on virtual machines, cloud or otherwise.
So what are some examples of those things that should stay in VMs?
There's not a really good case, for example, to say that a line of business application needs to run in a container. Something like a BI tool like Jaspersoft. It's not decomposable into microservices. It's not used as a front end to scale up a web scale application. It's just a standalone application that you use for doing what it does, right?
But can't you size the container with a more adequate amount of space than it would take up if you're throwing it on a VM?
Well, but you have to talk about the fact that, let's take a BI tool. It's not it's not delivering content, for example. It's not like a Netflix front end, right? You're not using something like a BI tool to say this has to be incredibly agile and has to handle 10x scalability differences between one time and another, right? It's going to run. It will grow over time as the data sets get bigger, but that's pretty gradual. The database gets bigger as I put more stuff into it. So it will have database creep, but it's still only being used by a fairly finite number of users, right? Maybe a dozen people are using this thing. It's not like saying, okay, it's Game of Thrones time, I've got HBO now, I need to stream this, and the demand for that on Sunday night when Game of Thrones come out is 100 times bigger than something else. Then you say, okay, that's where microservices really had a benefit. I need to have containers in order to be really agile about that. If I'm just sitting here just number crunching a bunch of data because I'm trying to do some kind of internal business analytics, that doesn't really apply.
Okay.
And you just don't get any real benefit. It's a lot of work,
and you get a lot of work for nothing.
Yeah, exactly.
Yeah.
So there's no benefit in size. The size of the VM is not going to be significantly smaller than that are significantly larger than the size of a container.
I just don't think the juice is worth the squeeze, right?
Yeah.
You're talking about like, okay, if it's something like a BI app or something else that has a big fat database attached to it, like the data is the constraint, right?
Sure.
The size of the data is the constraint. The amount of resources consumed by the overhead of the VM is of de minimis concerns to managing the size of the data, and the size of the data doesn't get any better by going to
In a container,
containers,
yeah.
right? And not to mention the database itself can't live in the container anyway. It's got to go live in something with persistent storage, right? And so your bottleneck's going to be, well, how fat is this data, and how good are my queries and all this other kind of stuff. And that, yeah, you could put it in containers maybe and shave a little bit off of like the CPU consumption, but that's not where the bottleneck is anyway.
I see. Are there any other cases where you would want to use explicitly, want to use virtualization over containers?
That's just one example. I think anything where you're saying that there isn't a big scalability component to it, anything where you're saying like decomposing it into microservices doesn't really gain me anything in terms of the flexibility of making it, reducing it to its smaller components doesn't really give me any flexibility.
So when you're saying the scalability component is what's really important, are you saying that like the speed to provision the container being much faster than the speed to provision the VM is really important?
I think there's a couple things. Microservices bring a couple benefits. One is flexibility and agility to have more granularity over the components of the architecture to allow you to fine-tune the performance, right? And so I can decompose the application, as much as I want in theory, right? Which allows me more granularly fine-tune each individual piece to give the most, right? In addition to that, it allows me to have a little more agility in terms of bringing stuff to market more quickly because, most developers think containers are easier to build on, so I can push things into production more quickly. If neither one of those are particularly true, if you're saying, well, time to market isn't of critical essence to me, and fine-tuning the microservices is not where the performance bottleneck is, or if you're saying maybe all this would be nice in a fantasy world, but the legacy code base that I have is not going to transition well, then you just won't be able to do it anyway. Are you familiar with what Sabre is?
No.
Okay, so
Sabre is an airline reservation.
Sabre is an airline reservation system. It's been around for multiple decades, right? And it is the back-end system that all of the airlines, at least the United States and maybe the world, use to book tickets, right? So all the stuff we have now, like Expedia and Travelocity and all those things, they ultimately have to connect to Sabre to actually get you tickets on an airplane. Sabre it runs on mainframes and maybe even older stuff than that. Like, it's not going to get migrated, right, to something else, right? And so then you're saying, okay, well, if my ability to have tickets get purchased more quickly is ultimately constrained by this legacy thing in the back end, making the front end faster doesn't help that much, right? So this is kind of the thing that I think is going to happen now is as we start getting into more mainstream, you're going to see more pragmatic analysis of where does it make sense to use containers, where are we going to really get the benefit from it? And then we get a few cases where they say, you know what, not really, we'll just keep things as they are and, leave them in VMs.
But when we're talking about the composition of new software, is there a role for VMs?
Well, yes. So there's just because everything I said still applies, right? If I came out with a new BI tool, right, I still have to worry about the fact that, well, there's persistent storage, and having a monolithic application may make it easier to, put everything together, or a marketing automation system, let's say. It's not necessarily, from an implementation point of view, if I'm buying an open source or I'm using an open source, marketing automation system, and I'm hosting it myself, and I'm not a SaaS, right, where I don't have to worry about expanding it to hundreds and hundreds of customers, the same logic I said still applies, right? It may be easier to deploy in a VM. There may be fewer moving parts in a VM. I'm still going to be constrained mostly, for example, by the data set, and I'm not using it to serve content to customers. So the type of application still matters, whether it's new or not.
Let's not forget that for now, containers are not easy, right? Everybody's super excited about them, but there's a lot that you need to learn, and not a whole lot of people who are very good at operating containerized environments
yet. That's why you developed Stacksmith, right?
It's a big part of it, yeah.
Can you explain more about the mapping between why virtualization allows you to do more stateful type of applications versus containers?
Or
did I misinterpret what you said?
I wouldn't put it in the terms of stateful, right?
Okay.
I think the difference is here is that if you have an application where the data component is as opposed to transactions, as opposed to pushing content through, right? If the big constraint on scalability is the fact that it's a fat set of data, and perhaps the visualization layer is relatively modest and doesn't need to scale to thousands of people, or it's not streaming content to somebody, right? Like I said, it's a tool where it's like, I'm trying to do some kind of number crunching on some data, I'm just trying to see it myself, right? Then we're saying, okay, the data is usually the main constraint on what can do it, and we have to worry about, well, how can I operate on that data? That's the performance bottleneck. And then I start talking about things like, well, do I want to run it as database as a service? Do I want to use something like Google, BigQuery? Do I just want to run it in one of the existing proven databases out there like MongoDB, right? And then all the other stuff that happens above that is sort of the icing on the cake to make it all work, right? So if I am a software developer and I'm, let's say, building, a market automation tool or a BI tool, people really care about well, what's your visualization? How good are you at displaying the data to me? The actual, until you actually get into really big data applications where there's a large volume of data, the actual number crunching on the data itself these days, it's a known science, right? We're doing pretty standard, database lookups, reads and writes and everything else, right? The art's going to come in onto the visualization. All of the stuff I just talked about right now, the databases are proven and well known. The developers are comfortable working on them in virtual machines and other kinds of environments because they've been that way for a long time, or even as a database as a service. And if I think about, okay, I'm going to have to have a copy of Apache and maybe Tomcat in there to do the visualization piece. If I talk about what do I gain by putting in a container, in this case, if it's just me and my department, not a lot, and actually I'm making the deployment more complicated, right? If the end user is not a software developer. What if the end user is the guy in the finance department, or the end user is the guy in the marketing department, or the end user is the guy in the procurement, or something like that, right? The thing that I think sometimes it's easy for people to forget is that there's a large volume of software out there that is in place that software developers pretty much never touch. Something like SAP, right? Big ERP systems that run, huge numbers of workloads, process large amounts of data, and there's a little bit of customization that happens in there, but it's all,
But they're starting to move toward using container technologies. I'm not just saying that doesn't mean, I hear what you're saying. I'm just saying is even these large providers are trying to think about this a lot differently. Right?
They are, but I haven't heard any of them say that. It's one thing to say I'm going to move to containers because I'm making a SaaS version of it, in which case all the stuff we talked about scalability applies.
Totally.
I haven't heard anybody who's in the kind of applications I've talked about saying that, well, we're going to move to containers just for the purposes of end user deployments.
So in your case with Bitnami and Stacksmith and then you're providing, maybe just describe Stacksmith in general so people understand exactly what it is.
Yeah, I actually want to clarify something from before, because I should point out that Stacksmith really solves right now the composition problem,
right,
not the orchestration problem.
Okay.
So what Stacksmith currently does is lets you choose from a set of Bitnami built known good components, like your database and your application, your language runtime, and then it builds a Docker file for it. You can choose a base OS too, and it will output a Docker file for you from which you can build a Docker container. The service is still in beta. We just released it in November. It's free to use, but there's a lot more coming around that to get you a lot further down the path. But we don't plan on solving the orchestration challenge. We plan on kind of tooling up the containers that we generate to plug in and be pre-configured to work out of the box with different orchestration systems that are out there, like Kubernetes, for example.
Right. Okay.
So one of the other things that I should mention that's, I think, one of the coolest things about it is not just the building of a Docker file, but also keeping everything up to date. So one of the biggest challenges is once you have all these containers up there, how do you keep them all, up to date and make sure that there are no security vulnerabilities? And since Stacksmith knows what you're building on top of, which components you've used, it can let you know via webhook or API call or even an email or Slack integration that, hey, this version of Mongo or whatever has an issue and you need to rebuild all your containers and redeploy. So that's where people are getting the most value out of it right now, is just making sure that they're keeping all of their systems up to date. And obviously there's a lot more coming around that.
So this kind of brings up the interesting question. This kind of gets back to what we were talking about earlier, which is, okay, how do I manage and automate containers at scale in production in a way that keeps them current and handles the diversity I'm going to have? If I start doing this seriously, I'm going to have a lot of variance in the image types between the different run lines, the different languages and frameworks and things like that. And then, depending on how your application is architected, you may have an all-container application, in which case perhaps you can, segregate how you manage that from your legacy stuff, or you're going to have it act in a way that it's in a heterogeneous application, where you can say, well, some of the pieces, because they're back-end legacy pieces that I inherited, are not containerized, right? I may have middleware in there. It may be talking to Tibco, which talks into something else in the back end. And then I've got to figure out, okay, now I'm going to have a lifecycle management where I do things in the container world one way, and then I have to deal with stuff that's pre-container another way. That could be like, this is like a BC-80 split now. We have pre-container and post-container. But that literally is the kind of paradigm shift we're going through. There's there's practices before containers and there's practices after containers. And one of the things that the more we talk in public, the more we hear about, is people are just starting to realize, like, okay, a container is not just a smaller, leaner virtual machine.
Yep.
It's a really different concept.
I think maybe in conclusion, what we can just discuss is how does Bitnami, in all of these, in the context of these discussions, how is Bitnami thinking about its own participation in open source communities? Here we are at OSCON. It seems like an appropriate question to ask.
Well, you are going to see some stuff coming up announced from us, things that we use internally that are going to be open source and available to the community within the next 3 to 6 months, I would say.
Yeah. I'm really excited about that. It's been a long time coming, and we're doing a lot of work to prep for that. So it's very cool stuff coming out.
That's such a trend, isn't it? To seek, for companies like yourselves, like who are like building things out and then open sourcing it. It's starting to see that a lot more.
In fact, over on the flight here, there was an entire Slack discussion going on about what are we going to name this thing, because if we open source it, it matters. We can call it whatever dumb thing we want if it's internal, but we're like, okay, we've got to pick something now that hopefully has some appeal to it. So that we're already having the what are we going to call this thing when we open source it?
Well, it raises a whole lot of questions.
And another thing that I'd say is we take it pretty seriously, and I think most companies have learned that now. You don't just like take code and throw it over the wall and release it under an open source license and you're done. You have to put a lot of thought into documentation and making sure that it's really ready for the outside world, and that you're ready to receive feedback and criticism and potentially contributions at some point. And so it's not something that we've taken very lightly, and we wanted to get the code to the point where we thought it really made sense and would be broadly applicable, because otherwise you're just putting code out there and no one cares, right? One thing that helped precipitate this, it's interesting, I think, is just in the course of building out Stacksmith and some of the other products that we have, we got a lot of feedback from users, particularly in larger organizations, saying, look, I need to understand how all of this works in order to use it. So, it certainly feels like the right thing to do, and we want to do it anyway, but, I don't want to be misleading and say that we haven't gotten a lot of pull to do this too. So there's a lot of demand to get access to these types of tools.
And that brings us to a really good point. So, in addition to open sourcing stuff, because there's potential that people will run with it and improve it and make it better, when you get involved in the kind of stuff we do, which is packaging and providing sources of content for people, especially with enterprises, there's a need for transparency to say, like, look, we may never modify the open source pieces that you guys are putting out there, but we absolutely want to look at, because under the covers we want to have some assurances that you guys are doing things in a way that they approve of and meet their security guidelines, and everything else. And open source has been pretty proven for being the way that people say, okay, it's all out there, guys, pick it apart and take a look at it. And that provides a comfort level to people who are thinking about looking at Bitnami for internal use as well.
Well, I want to thank you guys for taking some time to talk with us. Jeff, thank you for joining.
Thanks for having me
great
on.
questions. Really appreciate that. And Erica, always good to see you. And David, the work that you guys are doing is really interesting to us. I'd love to have a follow-up conversation about how you guys organize yourselves internally to be an internal-external organization. We just had this discussion with Capital One, and I think it's one of the most interesting topics that we can explore. It's like, how do companies actually operate internally with engineering teams, but also balance that, and show the value of being, very much in the open source community too.
Yeah.
So thank you guys.
Thanks, Alex.
Thanks for having us.
Appreciate it.
Capital One is our sponsor here at OSCON for a day of discussions about open source and why it is so important for new stack organizations everywhere. Capital One is at the forefront of this new open source world with several efforts such as the opening of its APIs and open sourcing core technologies such as Hygieia, its DevOps dashboard. Learn more about Capital One and its focus on developers at developer.capitalone.com.